In last video we were discussing about the acid base titration. In this video we will discuss about the acid base indicators. First we go in core concept of acid base indicators. Basically indicators are acidic or basic in nature, or in other words they are the uh, indicators are organic dyes which act as a weak acid or weak base. Its primary function is to signal the pH of the solution by undergoing the color change. In other words, indicators are used to show the completion of reaction by changing the color. They used in titration to determine the endpoint of titrations, and endpoints we know that comes after the equivalent point. Okay, about the equivalence point we have already discussed in last videos. Now we will discuss the mechanism of indicators, how it color change. First, indicators if in the form of weak acid, suppose that is represented by HIN. H means protonated. In other words, acidic. IN stand for indicators. Okay. If we take the example of weak acidic indicators, you can say that is a phenolphthalein. If we dissolve in the form of solution, it give its proton and form the conjugate base. Indicators show different colors in different environments. For example, if we suppose it is a phenolphthalein, that is the weak acid. In acidic solution, acidic indicator doesn't show any color, they remain transparent. For example, phenolphthalein, if we drop the phenolphthalein in the acidic solution, they show no color. If we drop into the basic solution, they show the pink color. It's mean acidic indicator show visible color in the basic solution, but they don't show any color in the acidic solution. Okay. HIN, that is the protonated form, and IN negative, that is the deprotonated form. You can say that is the conjugate base. According to the one of the theory that is known as quinoid theory, often involve the shift between the benzoin and quinonoid forms. They alter the way molecule absorb the light and resulting the visible color shift. Okay. If we see in the term of Lee-Chatler principle, how they show the color change, according to the Lee-Chatler principle, adding the acid or proton shift the equilibrium to the left, favoring the color A. It means no color. It means acidic pH is less than 7, show no color. If acidic indicators have a pH greater than 7, that is will be obtained by adding the base. It means they show color. For example, phenolphthalein that show the pink color in acidic solutions. Okay. Next we how we can find out the color change range with change in pH. We can understand this concept by using the Henderson-Hasselbalch equations. pH is equal to negative log of dissociation constant of the indicators plus log concentration of conjugate base of indicator divided by the concentration base of the indicator in the acidic solution or normal phase. If the pH is equal to pK of indicators. Concentration of two color forms are equals. It means observed color is a mixture of color A and color B. It means that is usually observed at the point of equivalence point, maybe sometimes. Okay, acid base color range we can see by solving the Henderson-Hasselbalch equation. If it is the acidic solution, then ratio of the conjugate base of concentration of conjugate base with the indicator less than 1. If we take its ratio, if we take the log of this ratio, if it is the basic solution, in the basic solution, it's mean it's the ratio log of the ratio is greater than 7. It's mean it's pH the color change with respect to pH change is plus minus 1. The transition states start from with respect to pH of plus minus 1. The human eyes typically perceive the complete color change when concentration ratio is 10:1 or 1:10. This means visible color change occur over the range of approximately a negative log of dissociation constant, dissociation of, in other words, ionization of indicators plus minus 1 pH unit. pH plus minus 1 mean if its color transition start when pK of indicators minus 1 is start of transition, and its color change ends start with the color A, and plus 1 mean its color end at transition color B. Selection of titration. Most critical aspects of choosing an indicator ensuring its pH transition range brackets pH of the titration is equivalence points. Strong acid and base equivalence point is 7. Suitable indicators is bromo thymol blue. Its pH range is 6 to 7.6. In this range it show the color. For the strong acid and weak base, there's less than 7 acidic. Most suitable indicator is methyl orange. Its pH range is color change range is 3.1 to 4.54. Weak acid and strong base greater than 7 is the basic. So its mean good indicator is a phenolphthalein. Phenolphthalein range is 8.3 to 10.1. Between this transition state at which color start to appear 8.3 and other transition state the point at which it ends the color further deep, that is the 10. That is a phenolphthalein indicator. That is its conjugate base in basic solution. That is the acidic solution. In basic solution it shows pink color. In acidic solution it does not show any color. In other words, it is the colorless.